Hello everyone, and welcome back to the channel. If you're a Tesla owner, you know these cars are incredible pieces of technology. But like any complex machine, they can sometimes throw a curveball. Now, you might be asking, what is an inverter, and why is it so important? Think of the inverter as the brain and the muscle of your electric drive system. Your Tesla's battery stores direct current or DC power, but the electric motors that turn the wheels run on alternating current or AC power. The inverter's job is to take that DC power from the battery and convert it into the precise AC power needed to make the motor spin. This process generates a lot of heat, which is perfectly normal. However, your car has a sophisticated cooling system specifically designed to manage this heat and keep the inverter within its optimal operating temperature range. When you see the P0C78 code, it means something in that cooling process isn't working correctly, and the inverter is overheating. This is a critical warning because excessive heat can damage the sensitive and very expensive electronic components inside the inverter. Your Tesla's computer is smart enough to detect this and will likely enter a reduced power mode, often called limp mode, to protect itself from further damage. You'll notice a significant drop in acceleration and top speed. So, where is this inverter located? Depending on your Tesla model, whether it's a single-motor rear-wheel drive or a dual-motor all-wheel drive, you'll have an inverter paired with each drive unit. The A in the code typically points to the primary drive unit, which is usually the rear one, but it could also be the front on some models. The inverter is integrated directly into the drive unit assembly, housing the motor and gearbox. Now, for the important part, how do we diagnose the problem? When we get a car with this code in the shop, our first step is to connect a diagnostic tool and monitor the live data. We're specifically looking at the temperature sensors for the inverter and the coolant. We want to see how quickly the temperature is rising. We also need to check the data related to the coolant system. Is the system reporting adequate coolant flow? Are the coolant pumps being commanded to turn on? And are they actually running? This leads us to the potential culprits. The most common cause for an overheating inverter is an issue with the liquid cooling system. We start by checking the coolant level. A low coolant level could mean there's a leak somewhere in the system, and not enough fluid is circulating to carry the heat away. If the coolant level is fine, the next suspect is the coolant pump itself. These are electric pumps, and they can fail. If the pump isn't circulating the coolant, the inverter will overheat very quickly. We can usually test this by feeling for vibration on the pump or listening for its operation when the car is on. Another possibility is a blockage or restriction somewhere in the cooling loop. This could be in the radiator, which is responsible for dissipating the heat from the coolant into the air. Debris, leaves, or dirt can clog the radiator fins, reducing its efficiency. There could also be an internal blockage in one of the coolant lines or passages. Finally, we also have to consider the cooling fans. These fans pull air through the radiator to help cool the liquid, especially when you're driving at low speeds or stationary. If the fans aren't kicking on when they're supposed to, the coolant won't cool down effectively, and the inverter temperature will rise. This could be due to a failed fan motor, a bad relay, or a wiring issue. So, to recap the fix, if you encounter a P0C78 code, the solution involves a systematic check of the entire inverter cooling system. We inspect the coolant level and check for leaks. We test the coolant pump to ensure it's functioning. We examine the radiator and cooling fans for proper operation and any obstructions. In most cases, replacing a faulty coolant pump or a failed fan, or simply topping off the coolant, will resolve the issue. It's a reminder of just how important thermal management is in a high-performance electric vehicle. Ignoring this warning can lead to very costly repairs down the line. So if you see this code, get it checked out by a qualified technician as soon as you can. I hope this breakdown was helpful and demystified the P0C78 code for you. If you have any questions or have experienced this issue yourself, drop a comment below and share your story. Don't forget to like this video if you found it useful, and subscribe for more deep dives into Tesla diagnostics and repair. Thanks for watching, and I'll see you in the next one.